29 all the way through 42. Again, 49. Not 49, 29 all the way through 42. Anything here? I think we should try something with xy equals 4 or xy equals 4. Look at that, both of them with xy equals 4. Okay, you choose. Or I will.
We do 31.
Okay, very good. So let's look at 31. In 31, let me just copy 31. In 31, we have 2x squared plus y squared equals 18. And we have xy equals 4. Perfect. Well, we cannot really do anything here. We have to think about this. We have to solve this equation, either for x and for y, and then plug it in. It's the only way, because I can't solve something like this for x and y because of the power that is there, the second power. So, which one would you like to solve for? Either x or y in the second equation.
Solve for x.
Okay, so if we solve for x, we have to divide both sides because they are multiplied by y. So it's 4 over y, which means now I have to go back here and replace x squared by 16 over y squared. So now 2 multiplied by 16 over y squared plus y squared minus 18 equals 0. 32 over y squared plus y squared minus 18 equals 0. I have no choice but to find the least common denominator. Can anyone give us the least common denominator? There is only one denominator that we shouldn't be thinking, which is?
Would it be y squared?
Indeed, there is no other denominator. So this one needs a y squared, and this one needs a y squared. So 32 plus y to the 4th minus 18 y squared. What did we say? In which situation a fraction is 0? Only if what? A fraction is 0 only if that would be a tragedy. When the denominator is 0, it's called tragedy, because it's undefined. Every time the denominator is 0, it's always a tragedy. So then what can happen? If it's not the denominator, it must be so a fraction is 0 only if the numerator is 0. If the denominator is 0, the fraction is undefined. Good. Now if you remember, this is power 4, degree 4, and we cannot, I mean we could, but what I'm saying is here we realize that it's quadratic in form. If you remember, we denoted this by t because this was t squared. So then t squared minus 18t plus 32 equals 0. Let's see if we can factor this. This should not be difficult. Although the numbers are a little bit bigger, it should not be a problem. So how do we factor this? Because here we said let t be y squared. Let t be y squared. So how do we factor this?
Is it t minus 16, t
Yes.
minus 2?
Yes. So then the options are t equals 16 and t equals 2. Is it done? No. Because now I have t, which is 16. So y squared equals 16. Because since the degree is 4, I expect 4 solutions. 4 solutions because the degree is 4. So therefore now we are going to establish 2 new equations. Which equations? That t equals 16 or y squared equals 16, and the other one y squared equals 2. What solutions do we get from these 2 now? And this is final for y, but then we have to go back and find x. So how do we address this? Meaning what method we apply here to find y? Which method from those 4 methods that we discussed a long time ago? Which one is the best to apply now?
The square root method?
Yes, excellent, thank you. We take the square root, it's already ready, but you cannot forget plus or minus. And here are our 4 solutions for y. So when y is positive 4, we have to find x. When y is negative 4, we have to find x. When y is the square root of 2, we have to find x. And when y is negative the square root of 2, we have to find x. X is 4 over whatever. X is 4 over 4. 4 over negative 4. 4 over the square root of 2. And negative 4 over the square root of 2. Now we have to rationalize this. So we will multiply the top by the square root of 2 and the bottom by the square root of 2, which actually is 1. The square root of 2 over the square root of 2. And let's see what we get here. This is 2, and we simplify it with the 2 from the top, so it's 2 the square root of 2. This is 2, and we simplify, negative 2 the square root of 2. So it happens that the system has 4 solutions. 4, 1. Negative 4, negative 1. The 1, 4. Negative 1, negative 4. 2 the square root of 2, the square root of 2. Negative to the square root of 2, negative the square root of 2. Sorry about that. But if I don't erase it right now, I may forget. And I send this to you and I confuse everybody. Okay. So 2 the square root of 2 and the square root of 2 and negative 2 the square root of 2 and negative the square root of 2. So these are the 4 solutions. 1, 4, 1, negative, negative 1, negative 4, 2 the square root of 2, the square root of 2, negative 2 the square root of 2, negative the square root of 2. Good. Did we get the idea with these nonlinear systems? Is it a yes? Is it a no? Do you think we need another one, or we move on to a word problem? Please say something, anything.
We can do a word problem now.
Okay, perfect, thank you. So I'd like to look at something like this. And you can choose if you want, or we can choose 45, it's up to you. So let's work on 45 and then we'll choose others if you feel like it. The difference between the squares of two numbers is 3. The difference between the squares of two numbers is 3. Can anyone give us an equation? Every sentence has a different equation in it, hidden in it. The difference of the squares of two numbers is 3. The difference between the squares of two numbers is 3. How will I write an equation with the information I have? It's okay if you're wrong. Just try. Anyone, please?
Would it be x squared minus y squared equals 3?
Of course. Excellent. Thank you. Good. Let's read on. Twice the square of the first number increased by the square of the second number is 9. Twice the square of the first number increased by the square of the second number is 9. I need another equation from this sentence, coming from this sentence. Do we need to read it again? Twice the square of the first number increased by the square of the second number is 9.
Is it 2x squared plus y squared equals 9?
Of course. What will you do with this? Excellent. Any suggestions for the next step? We need to solve. So how will I solve?
Would you just eliminate y squared?
Of course, by simply adding. Excellent. So 3x squared equals 12. Of course, I'll divide both sides by,
3.
of course. And when I take the square root, I get x equals plus or minus.
2.
That's it. So now, I go back anywhere, it doesn't matter. So let's say I go back here. So x squared equals 4. 4 minus y squared equals 3. I don't want to write it there, sorry. 4 minus y squared equals 3, which means negative y squared equals negative 1. 3 minus 4. So then, of course, I will multiply both sides by negative 1, and I get that y squared equals 1. Y squared equals 1 means taking square roots, y equals plus or minus 1. So, 4 solutions again. When x is 2, y can be 1 or negative 1. When x is negative 2, y can be 1 or negative 1. Any questions? Okay, let's look at another. Find the length and the width of a rectangle, a small television, such and such, the area of a rug. Any preferences? So let's work on one more. Any preference? Of course, notice that I started skipping the checking. The checking is always very easy. I shouldn't say always. Most of the time very easy. I should always go back and check. So for example, if you want to check 2, 1, 2, 1, 4 minus 1 is 3. 2, 1, 4 times 2 is 8 plus 1 is 9. You should always do that, especially in a test situation. Good. Moving on. Anyone would like to choose another word problem? Or I will.
58.
Very good. Let's take a look at 58. Find the length and the width of a rectangle with perimeter. So in 58, we have a rectangle with, doesn't matter how you denote it, let's say x and y. X is the length, y is the width. And the problem is saying, find the length and the width whose perimeter of a rectangle, whose perimeter is 40 feet and area 96. So perimeter 40 feet, area 96 square feet. This has to give us an equation. This has to give us an equation. Why? Because we have two variables and we have to have two equations. Good. Can anyone construct those two equations for us? Now you see the applications of these systems. We have a problem with two variables and we have two conditions. As long as we have two conditions and two variables, we can solve. That's the applicability of everything that we study with these systems, to apply them in real life situations. So, can anyone give us an equation for each? One for the perimeter and one for the area. Anyone, please? Any of those? Anyone remembers what the perimeter of a rectangle represents? Anyone, please? So the perimeter is x plus y plus x plus y. So the perimeter is 2x plus 2y, which equals 40. And the area, can anyone give us an equation for the area equals 96?
Would that be x times y
That's it.
equals 96?
Yep, that's it. First of all, I will simplify dividing both sides, the first one by 2. So then I have x plus y equals 20. And of course, like before, I'm going to solve either for x or y. Any preference? It doesn't matter. We have to solve for either x or y, the second equation. No preference, I'm going to solve for x again. So 96 over y. I have to put it in the first equation like before. So 96 over y plus y minus 20 equals 0. Everything is the same. The least common denominator is y. So I have 96 plus y squared minus 20y. Again, when is a fraction 0? Anyone remembers when is a fraction 0?
And the numerator equals 0.
Only, indeed, only when the numerator is 0. So from here I have y squared minus 20y plus 96 equals 0. So let me refresh your memory since the numbers are a little bit bigger this time. We go to apps and we choose 9. Yes, polynomial root finder. Yes, has degree 2. The first coefficient is 1. The next coefficient is negative 20. And the free term is 96. And I want to get the solution. So x equals 8. Or x equals, no, not x, it was, this was our y. So y equals 8 or y equals 12. From here, I have to find x. But I know that x is 96 over y. So a 96 divided by 8 and 96 divided by 12. Okay, so it was 96. It was 96, just making sure that my numbers, I can check at the end, but I'd rather check now to see if there is any issue. So I had x equals 96 over y, and 96 over y plus y. Yes, minus 20, that's correct. Okay, good. I'm checking again to see if I enter the numbers in here correctly. Negative 20 and then 96, and it was correct. That's correct. Okay, so then x equals 96 over y and 96 over y. Okay. So again, with my 90, let me get out of there. So I have 96 divided by 8. It's a little bit strange, but okay. So a 12 comma 8, we're going to check them in a moment. And then 96 divided by 12, and I get 8. Okay, fine. So then 8 comma 12. Good. Okay, that's perfect. So then, indeed x plus y is 20. 12 plus 8 and 8 plus 12, so this is okay. And the other equation is correct. So there are two possibilities, 12 by 8 or 8 by 12. Good. So this rectangle, and I already checked both equations, this rectangle has two possibilities, and you can say it's only one. I would have to agree, because 12 by 8 or 8 by 12 is exactly the same. Good. Let me look at the time. Okay, we have 3 minutes. Good. So what I would like to do before we stop for a little break, I would like to continue. Let me see my video here. Where is, okay, that's fine. The last section of chapter 5 is section 5.5, which deals with inequalities and systems of inequalities. So this is totally different. I'm going to start with inequalities first. We're not going to look at systems just this moment, just an inequality. So here's an inequality for us that I would like to pick, and I'm going to show you where I picked this from. So this is on page 601. And I'm going to pick, and I like something like this, or any. So let's start simple with 4. And then I don't want to forget, I want to look at 5 or 6, it doesn't matter. So 2x minus y greater than 4. Okay. In order to solve such an inequality, this is an inequality. As you see, this is not the equal symbol. This is greater than 4. our first step is I have to write the equation. Write the equation. Why? This is not an equation. Bear with me. 2x minus y equals 4. The corresponding equation. I need to graph this. Graph the equation. Okay. So when x is 0, y is negative 4. 0, negative 4. When y is 0, x is 2. So 2 comma 0. We've done this many times before. Okay. So in step number 1, I wrote the corresponding equation. In step number 2, I will graph the corresponding equation. Fine. 0, negative 4, 2 comma 0. I stop for a second and look at the inequality symbol. The inequality symbol does not have the equal symbol. Because it does not have the equal symbol, I cannot draw the equation as a solid line. So I'm going to draw it as a dashed line. I'm going to write the equation next to it. 2x minus y equals 4. Step number 3. I see that this line does not pass through the origin. Because it does not pass through the origin, I'm going to check with the origin. What does this mean? I go back to the inequality and I plug in 0 and 0. The whole thing is 0. Is 0 greater than 4? No. So the point, the region, as you see this line, divides the entire plane into two pieces, this piece and this piece. And I checked this piece because I used the 0, 0, and I got a false statement. So this region is not the solution. This one is. All points here make up the solution to 2x minus y greater than 4. Not here. I checked. If I had obtained a true statement, I would have chosen this area, all points here. But because I got a false statement, I have to choose the opposite. If the line passes through the origin, and I'll show that example, we have to do something else. But every time the line does not pass through the origin, we should always check with the origin. If it's true, I choose the area with the origin. If it's false, I choose the opposite. We're going to have more examples, of course, so we come back at 32.